Yeah, it's exciting to be able to talk about this. So my name's Andy Ash. I'm based in England. I work in schools. So after this meeting, I'm heading off to a school to do some work. And most of my work is around maths in primary and secondary schools in England. But I'm going to talk to you today, and as Carl was saying, please do chip in with questions the whole way along. That's always my preference. I hate talking too much because that's boring. Discussion is what's interesting. Um, I'm going to talk to you about some research I've done using LCT, which I did for my doctorate, which I finished about a year ago now. And it's something that I've been using within my work with schools since I finished that research last year. So, yeah, I'm just going to get straight to it. In terms of a sort of outline of what I wanted to do with you, I'm going to give you a little bit of background and kind of rationale. We are going to spend a bit of time thinking about this idea of representation, what a representation is, because I think that's fundamental to really understanding how I've used legitimation code theory and semantics. So we're going to spend a little chunk of time doing that, and I'm going to get you to do some thinking as well. And then I'll look a little bit at the kind of methodology that I used and then some kind of data and how I've used semantics to analyze that. So yeah, please do chip in. I probably can't see the chat as I'm going through because it's quite hard to see the chat and stuff. So just unmute and shout out. That's absolutely fine. Um, so first of all, as I've said, this was part of my PhD. And as you probably guessed from what I said right at the beginning, I was researching the kind of world in which I also work. So I run an organization which is called a Maths Hub in England. We provide professional development to teachers. I also run maths across a group of schools that has from age kind of 4-year-olds all the way through to 18-year-olds. So I'm working with teachers every day and school leaders and things like that, but I was also researching and studying what was going on in classrooms. The second important thing here is that in England, there have been kind of mathematics curriculum reforms that have been going on for over 10 years now, really. There's a lot of funding that's been put into this from the government, and that because of this, teachers in many schools across England are part of lots of professional development that's kind of happening across the country. And so that's the kind of context within which I'm working. And I guess specific to what I'm going to talk about today, within those kind of reforms and changes that are happening across the country, teachers are being strongly encouraged to use a wide range of representations. So the idea of representation teaching interested me anyway, but it was deeply connected to the context within which I'm working as well. So there's kind of a dual thing going on there. So that just hopefully gives you enough of a background to when we're looking at some of the data, and I'm talking about the research I did, it sort of provides some of the context that I'm working in, really. So I guess the bigger picture here is that all of my work so far has been about how this thing that we call mathematics that exists in the real world is a subject that has kind of developed over time, and human beings have added to it as we develop new ideas and new thinking in the world of maths. And really, I'm focused on how that is recontextualized into what I just call school maths. And this is lots of you may be familiar with the work of Basil Bernstein. He talked a lot about knowledge recontextualization. So I'm very interested in how a subject, some knowledge in the real world becomes translated into something that is learned about by students in school. This quote here from Liljedahl really, I feel, sums up a lot of what I've done. Because what he's saying is that when teachers or curriculum designers or textbook writers, all these people, when they choose a particular piece of content, they're selecting an offer of meaning. They're taking a subject or knowledge in the real world and choosing what part of that is going to be learned and understood and focused on within the school version of the subject. So I'm going to talk about maths today, but you could apply this to other subjects as well, couldn't you? So geography. So in the top left, there's Professor Bob White. He has done lots and lots of research about volcanoes and volcanic activity around the world. So it's very real life stuff. And we could think about how these big ideas in a subject like geography become recontextualized into school geography, where students are learning about things often in the classroom, and they're interacting with that knowledge in different ways. So although I'm going to talk about maths, I would encourage you to think about how the things we're going to be talking about relate to any other kind of subject where we're taking a real world thing and translating it into the classroom. So how I feel that this deeply connects to representation is that if choosing content involves selecting an offer of meaning when you're translating these subjects into the classroom, well, actually how you represent things is a key part of that choice. So when a teacher or a textbook designer or a scheme writer or a school leader decides that we're going to use this particular thing in the classroom in this lesson on this day or over this sequence of lessons, they're selecting an offer of meaning. They're saying, we feel that this representation of this idea is really important, and it has value, and it's necessary for students to learn about. So today I'm going to talk about representation of mathematical concepts and the choices and ways in which they're used in the classroom. So thinking about that, I've got a question for you. If I put a representation on the screen, I'll put it on there in a minute. I'm just interested. Could anyone tell me what this is or what it's representing? So here's a representation. It is not a trick question. Do you know what this is?
Looks like a Greek lambda.
Yeah.
So, okay.
But it looks stony. Like
stony. Okay. Any
Could be an
other thought?
upside down, small y.
An upside down small y. Sometimes teachers tell me they think it looks like a diplodocus. Does anyone actually know what it is?
no.
No. What, out of interest, what would have to happen to know what it is? What would need to be the case for you to know exactly what this represented?
To have some sort of context.
Maybe where it came.
Sorry, go on.
Maybe where it came from.
Yeah, where it came from. So as I said, it's not a trick question. This just gets us thinking. So with representation, sometimes actually to understand what the representation is meant to be representing, things have to happen. We have to be told stuff. We need some context. We need something else that's going to give us an indication. Well, let me put another representation up for you and ask the same question. Do you know what this represents? And again, it's not a trick question.
Yeah, that's a number 3.
Number 3. So can someone give any thoughts about the kind of thing that this could represent? If you give me some maybe real life examples or something. Any ideas?
3 apples.
3 apples. Okay. Anything
Blind
else?
mice.
3 blind mice. So a nursery rhyme.
Time.
A whole range of things. Sorry, go on.
No, I just said time. Could represent.
Time, right. So 3 hours, 3 o'clock.
It's a particular number of some number of things, like 1, 2, 3 of something.
So a quantity, like an amount of something. Yeah. Okay. So I'm interested then. Why do you think it is that we looked at this one and we were like, is it an upside down Y? Is it some kind of letter? And we were quite clear as a group. We don't know what this is, right? Why is it we know what this is? That this represents a lot of things. We could have carried on that conversation, I think. What's happened to allow you to know what this represents?
Past experience. We're familiar with
familiarity.
So familiarity and past experience, right? Out of
fewer
interest.
Context, but there were fewer contexts for that. We've only ever seen that symbol on the whole as meaning one thing, whereas I've seen lambda as a Greek character. I know it as lambda calculus. I know it as a sort of variable. So there's lots of things it could mean. And we've seen 3 in all sorts of drawn in all sorts of ways, including with a stony background, whereas a lambda with a stony background suggests it might be off the Rosetta Stone, or it could be something else other than the mathematical symbol that I know it as.
Yeah. So we've had experiences connected to this representation here, this symbol, that mean that we can connect a lot of other ideas to it, right? Just the next slide.
Sorry, Andy. I just thought
it
was interesting that most people who were talking about not knowing it were talking about like experience and things like that. But my brain went first and foremost to the semantic structure of which 3 is a part, rather than my own personal experience of anything. So I know 3 because I know the entire semantic structure. Well, not an entire, but a functional enough amount of the semantic structure of which that is a part.
So you are connecting that to other experience and knowledge you've got about it.
No, I wasn't talking about my experience at all. I was just talking about the semantic structure of which that is a part, which are whole numbers. I know the whole number system, so therefore I know that.
So a question then could be, do you feel that you understand everything that this could be representing? Does anyone think they understand everything that this could be representing?
Probably not.
So this just illustrates something, right? Which is the number 3 is something that very young children learn about in school, isn't it? So usually around maybe like 3 or 4 years old in most countries. Yet even as adults, we're kind of saying, well, here, this is a concept. It's an idea that connects to lots of things. And we probably couldn't even tell you all the things ourselves because it's quite complex. So these are some of the things, when I work with teachers and I show that we talk about this, these are some of the things that they come up with. These are all things connected to this representation of 3. So really the point of this is to illustrate, I guess, what it might be seen as the problem with representations in maths. And I think we can think of it in other subjects as well, which I'll demonstrate in a moment. But when we think of a mathematical concept, it's abstract and it can only be communicated with representation. So the numeral 3 there is one representation that's commonly used in most countries. But the problem is that no single representation is that concept itself. So we could go back to this and say, well, is any one of these things the real number 3? Mm-hmm. And I think the answer is, well, no, they're all number 3. And therefore it's really complicated because to understand a mathematical concept like 3, which most people would say is quite a simple one, well, we can only understand it if we engage with multiple different representations. So deep understanding of a mathematical idea means that we need to be exposed to and interact with multiple different representations. So we start to see different aspects of that idea. But the problem is using multiple representations is actually often confusing for students. So in fact, let me demonstrate it. Let me just talk through a real example of how students might learn about fractions. So, for example, when they're quite young, around 7 years old in England, pupils start to learn about fractions. And so they might learn about this idea of 2/4, and they learn that I can say it as 2/4, I can write it as words. I can even shade in shapes. And when I have a shape like a square and I chop it into 4 equal parts, the name of each part is a quarter. And so I write that as 4 in the denominator place. And if I shade in 2 of them, then I've got 2 of these quarters. So I know I've got 2 pieces that are called a quarter each, 2 quarters. And they become quite comfortable with that. Okay, yeah, I think I get this idea of 2/4 or of a fraction. And then we introduce something else. We say, oh, by the way, actually, you can also represent 2/4 by a proportion of a quantity. So if I have 8 things, 2/4 of it is 4 of those things. And by the way, actually, 2/4, I know it's got a 2 in the numerator and a 4 in the denominator, but actually 2/4 is a number on its own, and we can put them on a number line and we can count in quarters, 1/4, 2/4, 3/4. And it becomes a little bit more confusing because hang on a minute, I thought I understood 2/4, but now I've got to connect these other things to my concept of 2/4. And eventually, okay, well, I think I've got it. These are all different ways of showing 2/4. And then we come along and we say, well, by the way, if there were 2 pizzas and I shared them equally between 4 people, which often we know that sharing equally we can call division. That would be written as 2 divided by 4. By the way, that's the same as 2/4, because when I share 2 things equally between 4 people, each person gets 2/4. Oh, this is getting quite confusing. This thing I thought was quite simple, 2/4, is becoming pretty tricky. But eventually they go, oh yeah, it all relates to 2/4. I understand it. And then again, we throw another spanner in the works and we say, oh, by the way, if you had half a pizza, and you wanted to find 2/4 of that half, 2/4 multiplied by a half, this is actually equal to 2/8. And that picture there, by the way, is my artistic attempt to draw someone's mind blown. But this, I think, just illustrates the problem, which is that we do need multiple representations of an idea. They are important in terms of developing a full understanding of that. But the more we introduce different representations that apply to different facets of this mathematical idea, I've used 2/4 as an example, the more complex it gets and the more confusing it can get. So just to reiterate that, and this is not, I haven't discovered this is quite well understood in other research, that multiple representations are important if we're going to have deep understanding of ideas, but using multiple representations can be a problem. So I guess this is a dilemma for teachers. The dilemma is I need to use multiple representations to help pupils understand, but using them can make it really tricky and difficult for pupils to understand ideas. So how do I negotiate that as a teacher? How do I deal with that? So just to take it outside of math for a minute.
I think you're just about to do what I was thinking, which is, sorry to interrupt you. I was just thinking about how this reminded me of like the use of analogies in history, for example, or geography. You know, like there's one that I analysed in a paper about a teacher trying to get students to find the center of the Roman Empire on a map, and Italy looking like a boot, and that's a representation. But then that particular thing crashed because then all the students were just trying to find boots. So, but yeah, it's like, it's not just maths, is it?
Yeah, well, I my area of specialism is maths, but I talked to a colleague as a geography teacher actually, and to try and come up with an example of a different subject. So I thought about how we represent the world, right? We use maps. You were just
well, that's wrong, Andy. Like, that's wrong for a start. Australia should be in the center at the top, and the McCarthy Universal Corrective Map of the world.
Yeah. So here's a map, but here's another map. Hang on a minute. I thought Africa. How big is Africa, right? What about this one? Something's going on here. And this one, I can't even find the countries I thought I used to be able to find on the map. So you can see that in many subjects, we need representations to understand ideas and interpret ideas in school. However, the more you introduce different representations, the more complicated it is. It just reveals the complexity of some of the ideas we're trying to get students to engage with. So that is the problem that I kind of started with. I kind of thought, okay, well, this is something I'm seeing all the time in my work. I know in the context of England and what's happening in England, teachers face this dilemma all the time because they're being encouraged to use more representations to develop this deeper understanding, but it often goes wrong and it becomes confusing, and we're not necessarily seeing what we want to see, which is pupils developing deeper knowledge of ideas. So this kind of sums up the problem. Before
Andy, can I just ask? I'm sorry to interrupt. Well, but Carla invited us just to barge in. On your first bullet there, mathematical concepts can only be communicated with representations. And I'm kind of thinking, is that true of all concepts, actually? I don't know, what would you say that concepts can only be communicated with representations? And then I suppose immediately I'm like, well, what about language? And is language just discourse? Is that a representation?
That's a good question. And in my experience over the last few years, people really like to debate this. So in mathematics research, they like to go, well, math is the only one where you have really totally abstract things and you can only do this. But then even in like chemistry, there are arguments around, actually, there are aspects of chemistry you can't go and find the stuff. It's impossible to see. So you can only deal with representation. So I think, and then people who are involved in like religious education and things, they would say, well, what about love? How do you find that? You can't find that. You can only find representation.
Or an English teacher might say, what about guilt? And then, here comes a kid and says, oh, well, Hamlet, that's the play about Scotland. And it's like, well, no, it's about guilt, really.
Yeah.
This is all, I don't know, the notion of concept, the concept of concept, sorry, I went there, is complicated, and it surely is at the heart of this.
There's also going in another direction in computer science, which we're now doing in England in primary schools as well. Representation is a very concrete thing that we're actually studying representations because you make them very solid because you're implementing them in a programming language. So you have to come up with a representation of whatever data it is that you're manipulating. And we're actually doing some kind of explicit study of representations, whereas here it's happening in the background, but actually it's part of the syllabus in computer science.
So they study
how it interacts with these kinds of ideas as well.
Yeah,
because we have to teach what a representation is, and the fact that you can have different representations of the same data because you just implement them in different ways, whether it's in even with numbers.
Yeah, that's really interesting. I think that's really this sort of.
Andy, I just want to just pick up on a moment there to think this is really interesting as a sort of general learning moment in the sense of when dealing with talking about knowledge practices, one has to somehow skirt around without falling into issues of epistemology and ontology, which people sometimes, particularly you've not got this problem because you've finished your PhD, but many a PhD student has been lost to falling into issues of epistemology and thence into ontology and thence into the philosophy of knowledge, and they've never come back. Like people entering a maze and never coming out again. So somehow being able to go, I'm not doing these things, and everything is a representation, but we're just talking about the number of them here. And also, I think the thing you said, which is really interesting, is to avoid this exceptionalism that every single discipline has and every country has around the world. Whenever I talk with all these wonderful people across, all you wonderful people across all these areas of education, every single subject area believes it's unique, and every country believes it's unique, and yet the same problems are appearing everywhere. So you're going to have to, everyone here, I suppose, in a way, is going to have to navigate and avoid falling into these pitfalls of having a sort of, an endless discussion of epistemology or this sort of notion of, exceptionalism. Unless, by the way, you're playing to the crowd. So if you're doing this talk to mathematics people, you can definitely go ahead and get the sympathy on the, it's us and we have a difficult time, worse than anyone else.
I have to say I did go down the rabbit hole of the epistemology ontology. There are many papers about whether mathematical knowledge objects are real and whether they have existence or not. But I'm pragmatic, and I think this is about teachers and what teachers can do and how they're doing what they do in the classroom, rather than arguments about the existence of these things. It's a different thing.
That's exactly right, Andy. What you've got to do is to remind people that these are different fields of practice, and you're analysing the I hate these terms, I've renamed them in the new book, the curriculum field and pedagogic field, and not the research field. You're talking about knowledge that is being recontextualized into curriculum and pedagogy, and how to deal with that. not with the nature of the thing that's being taught. And then you can skirt around those issues, you know, and not fall into that endless discussion, which doesn't help anybody much.
Yeah. Yes. So I think it's important to be aware that there's a lot of research and writing around representations in relation to maths, as I think there are in other subjects. I'll just quickly flick back and forth. So what I did was a bit of a review, well, a long review of literature, and so there are lots of references there, and they relate to, these are the things I think the research says about what we know about using representations and multiple representations in the school maths classroom. So I won't read it out. I'll give you a minute just to take it in. So I looked at this and I think actually this is quite useful. This starts to help me understand how teachers can think about what good use of representations look like. So this for me is a starting point. It was a starting point for what to look for in research, and a starting point as well when I'm working with teachers. So the important thing is that this is a sort of a starting point. And so if we think about multiple representations, just to kind of exemplify one of the things that's on there, a common way of thinking, and again, this is internationally, this is not just in England, although we do think like this in England a lot of the time. People like to think of things like concrete representations, like real things that might be 5 real apples. And we can then translate that into a pictorial thing like 5 dots, and an abstract representation like the symbol for 5 or the word 5, which are quite removed from the real thing, the apples, but we can use them to represent it. Equally, we could take a more complex example like an addition, and we could represent it with concrete mathematical equipment, like we call those deans or base 10 in England. We could draw that, so there's a student's drawing of it on a whiteboard, and we can use, again, words which are abstract in relation to maths, or symbols, the mathematical symbols, to represent it. So that's sort of often how teachers are encouraged to think about this. So I think that that slide and the previous slide, for me, these are existing frameworks and they're really useful. They're descriptive concepts. They act as a starting point for teachers. So, you know, I wanted to make sure that I was acknowledging that, and that was built into kind of my research framework. But what I want to talk to you about today and show you today is really how using the legitimation code theory semantics dimension kind of presents a new way to build on these and really explain how teachers enact some of those things. So the term I like, and it comes from Anna Svard and Paul Thompson, which is a paper from quite a long time ago. They describe the need to think about representational activities. So a lot of that research I was referring to before just looks at representations and how we codify representations. But actually what we need to do if we're thinking about classroom practice is better understand the activity that's going on and how representations are used by pupils and teachers together. And so that's the sort of little niche that I became very interested in, and I think that semantics really helps with. So hopefully I'm going to show you that today, and we can have some discussion around it. But it's that please sort of hold that in your mind. It's the how teachers are using, or how teachers and students are doing representational activity in the classroom.
Can I just ask for a clarification, Andy, on what Svard and Thompson or what you understand by representational activity? Does it mean the act of creating presentations or representing things, or is it about taking an existing representation and how we use it?
I think it's both. So what they would say is that even if you're taking someone else's representation that's been created, such as counters, right? They would say that in the process of using them in representational activity, you are creating your own representation, because if I arrange counters in a specific way, that's my way of using it and interpreting it to represent an idea or a thing.
Yeah. Thanks.
So I'm going to talk about, I'm going to move on to talking about my sort of study, what I did, and we'll look at some stuff about semantics. So the research question I set out to look at was this. I'll give you a minute to read it. So as with most doctoral research questions, it's kind of long and very specific, and there were quite a lot of elements to it. Today, in this roundtable, I'm really just focusing in on this part. It is the use of representations or representational activity. So lots of other things happened, but this is the sort of real focus for this discussion. So I actually did a case study of one primary school teacher who I gave the pseudonym Gillian. That's not her real name. So primary school is what we call schools in England, which start with pupils at the age of 4 years old and goes all the way up to the age 11. So 4 to 11-year-olds. She led maths across her school. It was a smaller than average school, so roughly 240 students in her school. And it was in the north of England, just to give you, if you know England, some kind of context. In terms of what I actually did in terms of data collection in the case study, I actually, one of the benefits of doing a case study of one teacher was that I could go really detailed with my collection of data, as in collecting a lot of data, and then really detailed in my analysis of that data. So I watched her teach 3 lessons, and I watched them, made notes, and I video recorded them to refer back to. I then did what are called stimulated recall interviews, which is where me and Gillian, I had some structured interview questions. They were semi-structured, so it was fairly loose. And we watched the video of the lesson back, sort of fast forwarding, pausing at bits, and she could pause or fast forward and pick on bits, and so could I, and really discussing what was happening in the lesson. And the purpose of that is to really ground the interview so that we're talking about real things that she had done in lessons that we had both been a part of, if you like. I did something which I refer to as a teacher problem task interview. I gave her maths problems. Some people say it's a bit mean, but I gave her difficult stuff to do with fractions and representations, asked her to do them, and then talk through what she was doing with me so I could get a sense of her knowledge of some aspects of fractions and representations, and we could talk about it in a metacognitive kind of way. She was also using a textbook, and I analysed the textbook, all the fractions within her textbook she was using to understand how that related to what she was doing in the classroom with representations. In terms of how I analyze the data, I did what's called a hybrid approach to thematic analysis. Essentially, this means, I did say earlier on, I'm a pragmatist, and it's a pragmatic approach. So it's not sticking blindly to a pure approach to thematic analysis. It actually involved 3 phases where I essentially started off with a standard thematic analysis where I looked for themes, codified the data, and looked for themes that were coming from the data using this kind of process of inductive reasoning. So I was really trying to understand the data in itself and what was within that data. I also then used some of that stuff I showed you earlier from the literature to try and look for, well, what was Gillian doing in relation to what the literature said about use of representations. But the thing I'm going to talk to you about today is the 3rd phase, where I then applied. I actually used 2 areas of legitimation code theory, specialization and semantics. So I'm just going to pick on the work around semantics today. Before we get stuck into that, has anyone got any questions or comments about that kind of the methodology I used or that approach? Anything in particular about that you wanted to ask? Fine, if not.
Can I ask one thing, Andy? And it relates back to your research question.
Yeah.
And it may just hinge on a word, but it describes the meaning of fractions, the mathematical meaning of fractions. And I just wonder whether it would be different if it was how teachers, how does the use of representations in the process of negotiating mathematical meaning of fractions? Like, is there a mathematical meaning of fractions the right answer? And did you have to presume that in being able to make a judgment in your subsequent analysis?
I would say probably the use of the word that is not. It could have been negotiating mathematical meaning of fractions or the mathematical meaning. I didn't presume that there was a singular meaning. So I used a research-based a way of looking at fractions, which shows that there are sort of 5 different structures that relate to fractions, and each structure has many representations that connect to it. So there was a framework behind that, but I didn't want to presume that there was just a singular meaning, if that makes sense.
Right.
Yeah. Okay, well, let's look at semantics and what I did. So I know many of you will be familiar with semantics, but I didn't want to assume that everyone here has got deep knowledge of it. So let's just do a little bit of a going over what we mean when we talk about semantics within legitimation code theory. So first of all, for those of you who are not familiar with it, it focuses on 2 areas of practice: context dependence and complexity. And I'm going to exemplify that with you. So it should make sense shortly. Lost my clicker. It's different from the use of the word semantics in linguistics. So it's a different thing. We're not talking about the same thing. And it's built from 2 concepts. So one of these is semantic gravity, the extent to which the meaning being communicated or used is dependent on a context. And the second being density, which is how complex or clustered meaning is. And again, I'm going to exemplify these. So if it's not making sense to you yet, hopefully it will once we've looked at some examples. And so the concepts semantic gravity and semantic density, we can put them together and we can explore semantic codes, again, which I'm going to exemplify in a moment using some mathematical representations. So if we take this, so this is an image from a textbook used in England. We can see there's a question number 2 with part A and B, and on this question we've got a rectangular representation with shaded parts. It's labeled with numbers, percentages. We've got fractions. We've got the equal sign, and then we've got part B underneath it. And if you look carefully, you can see that the authors of this question, I think, are really pushing for people to see a connection between 1/10 and 1/5 and 3/10 and 3/5, and to look for perhaps patterns and things. So if we take this as a question, and we think about semantic gravity, remember, which is how context dependent something is, I would interpret this as being having a very low level of semantic gravity, meaning that this is not directly connected to a context. There is no kind of specific application of this within the question to something like money or percentage of, I don't know, an area of a shape or something. Although the shaded diagram is alluding to that, it's not directly connected to one context. And so in my work, I kind of defined something with mathematical representations with a low semantic gravity as this definition here. I'll let you read it. So representations being devoid of context and used to support generalizations about a concept.
Personally, I would always just avoid or anything that's completely absolute, because all strengths are relative.
Yes.
So I would just say relative. I'd never use full on 100%, 0% terms, because it's just always relative.
Okay.
The other thing is that Yeah, the thing is, it's just also a hostage to fortune because people say, well, mathematical knowledge is a context.
Yes. Okay. Yeah. Thank you. If we take this, so this is an image from the same textbook, actually, and the same year group. And if we look at this, we can see in this image, we've got some children some of whose heads are cut off. They are arranging some chairs in rows. So if we think about this as a representation in a textbook, for me, this has a high level of semantic gravity. So this is directly connected to a context. It's people putting chairs in rows. So I describe this as representational activity being connected to real life contexts. And the emphasis is on understanding that context itself. So I think an important thing to say here is that what I'm doing with you is showing you some representations that teachers might use in the classroom. In order to really analyze these using semantics, for me, you have to see them being used in the classroom in a social situation, because that's when you know how they're being used. So I'm making some assumptions just to demonstrate with you here, and we'll look at some of the real data where we've got that information shortly. So if we then think about semantic density, density being the complexity of meaning, this same representation, I would interpret of having a really, as being quite dense. There are different representations being used here. So there are multiple representations being used, the symbols and the diagrams. And the question seems to suggest that they want someone looking at this question to make a connection between these. So it's really quite complex. So it's got a high level of semantic density if I was going to use it in that way. Equally, the one we looked at before with the chairs, I would say has a low level of semantic density. It's quite simple. The question seems to be focusing on a fairly discrete piece of knowledge, which is arranging 24 chairs, and it's not being connected to other areas. So it's fairly simple. So it doesn't have a high level semantic density. So what I did was I turned some of this stuff into a translation device that was going to help me analyze my data. So when it comes to semantic gravity, this was the translation device that I use, and which I'm now going to adapt slightly based on Carl's feedback. So you can see here, I was thinking about what's really strong semantic gravity like and what's really weak semantic gravity like, and where are some of the slightly grayer areas in between. I'll let you read it for a moment. I know it's a lot to take in, but we'll demonstrate it as well.
While people are reading, I'm just going to give a handy hint, which is not available yet because it's in the book I'm writing, which is when you're describing semantic gravity strengths levels in writing or in a talk, it's a lot easier to start with the strongest and work up from there. And it's also the same with semantic density, to start from the bottom, the simplest. And that's because with semantic density, this is when you're the sequencing of describing, because you can describe something and then you can describe something that's a little bit more complex, add something, and then something that adds something to that, and then add something. And it's really easy for people to follow. And it's the same thing with semantic gravity, is you start with the strongest and then sort of say, okay, take that away, often for the bottom half. And then for the top half, it often then tends to be, now we're looking somewhere else. It's sort of, kind of, and it starts looking up to the sky, as it were. It's just, I've always found it that way. And Matt Lewis has just asked, does context necessarily imply real life? No. What it does, though, is that it tends to, I mean, the really short answer to that is that we could say anything's a context if we wanted to, but in order to be able to set semantic gravity so that we can talk about different semantic gravities across studies, we tend to think of stronger as being down, and to be more kind of social or concrete, or however it is described. It can be so many different things. So, and then we think of more abstract away from that.
So I think that's a good question, Matt. For me, I interpret it in this way for my study because I found that using it in this way to trace or really study classroom practice was helpful. And hopefully I'll show you that in a minute with some of the
another
data.
way, I just wanted to answer Matt's question. Another way of there's so many ways in which semantic gravity appears. So, for example, one I've given before is about how it can be similarity to something, some anchor, like, for example, a musical score, which then, in jazz, you might stay quite close to it and then move away from it and then end up with free-form jazz, nothing to do with the original musical score. Or the same thing is like there's an event happens and then you have a pictorial representation that's like photorealistic, and then there's one that's more like a cartoon or something, and then end up being diagrammatic. There are so many things that can end up being analysed using semantic gravity. So no, it doesn't always have to be real life.
Yeah. So can I just ask, so about your abstract example with lots of representations, when I first saw that, I thought that is giving some context, because as I was reading it, I was seeing the top example is giving you a context to help you understand what you're supposed to do in the bottom. So I agree, it's still all incredibly mathematical, but I mean, maybe this is part of the thing that the axes go on forever. That you could be a lot less context, because that has a certain context. It's just a mathematical context to help you understand what you're expected to do to fill in the others. And actually, if you only had one of the rows, if you only had the bottom row, that would be even more devoid of context.
Yeah, I think this is the relativity thing where that comes into play, isn't it? And for me, this is where having this translation device was important, because I could say, right, within primary maths, which is the context, this is the relative things I'm working with. But I agree, you could keep going. And the other thing I grappled with, which actually I'll put the other translation device on the screen. Let me find my cursor. Is how semantic gravity and semantic density differ in relation to mathematical representation. So it took quite a long time to arrive at this. And again, it is just my interpretation of it within my study. So I thought of semantic density in relation to representations in this way. I'll give you a moment again to just have a little look.
Andy, something that's just not clear to me, but I'm actually referring to the previous slide, which I'm just seeing if it's here as well, is that there seems to be, you seem to be distinguishing between SG++ and SG+ based on the focus of what the activity is directed to, rather than the degree of context dependence. So if they focused on the context for the context's sake, then it's SG++. But if they focused on the context for the sake of mathematics, then it's SG+. So I'm just trying to grapple with whether that's actually a shift in semantic gravity, or whether that's just a shift in focus.
So maybe, so what would be useful is to have a little look at some data, I think, and maybe that will help facilitate the discussion, because again, it's my interpretation and I'm really interested in other people's thoughts about it.
That's why, Andy, we normally have examples in translation device tables.
So, well, I do in my other one, but I thought actually for this, I've got the actual examples that we're going to look at shortly, if that's all right.
I mean, it's really interesting, Andy, because it's back to what you said, and sorry, I don't want to stop you showing the data, because it's how it's used. It's that representational activity that's interesting here, because in a sense, I'm looking at that chairs example, and I'm kind of thinking, well, actually, kids playing with that, they might end up with a much deeper understanding and meaning, because they go through the process of making it abstract and realizing there's something about the structure of the 24 and how they can divide it up, and they're acting on something. They create, it's much looser in a sense, and if they might arrive at a much deeper meaning of fraction and connections, other connections with number, whereas the first one, where there's a sort of a given like bar chart, they might actually, that maybe restricts their understanding to, and I hate to use the word, but to that particular context, to that particular representation. But it all depends on what actually happens with the teacher and the learners, you know. And Lee, your point about SG plus and SG plus plus, I mean, whether the kids focus in on the mathematical elements or whether they look at the context itself, well, we don't know until we see what actually happens. So it's not the mathematical task which is presented that has all of these semantic gravity and density. It's actually how it's used. Is that right?
That's how so you've kind of read my mind because this is the point I think it's really important to make. So let me just move the pictures out of the way so I can actually see. So if we took this one, the one that you've just picked on, Matt, and we said, okay, well, what happens then if we have this image on the screen in a classroom, for example, and the teacher then says, okay, well, how can we put the chairs in equal rows? And I wonder how many different ways there are to put them into different rows. Well, that's going to start shifting, and this is going to become more semantically dense. It's going to be more complex because it's going to require pupils to think not so much just about putting some chairs in equal rows, but actually, I wonder how many different ways they can go into equal rows. And eventually, in this lesson, for example, I'm going to end up thinking about factors, which is much more complex than simply putting 24 chairs into some equal rows. Equally, if I took this one, and let's think about how a teacher might use it. Well, a teacher could just say, ignore the bar diagrams and don't worry, just do 2A. When you've done 2A, we'll look at the answers and then do 2B, and don't worry about anything else. Well, by using it in a different way, you're reducing the density, and you're changing actually what's going on with this representation in that kind of social situation. So this was really important for me in my study, because I wasn't so much interested in just the representation itself, but it was actually what was going on in the kind of classroom in between the teachers and pupils. I think that's kind of what you were getting at, Matt. I'm not sure, Lee, if that's kind of what you were hinting at with your question. I don't know. What do people think of that? This idea that you can't really just I feel you can't look at the representation on its own. You have to understand what's happening in the social situation within which you're trying to understand. That was very important for me anyway.
I think it's also, you can't just be watching what's happening in some sense. This is what I just put in the chat. You really need to know what's going on in the kids' heads, because they could be passively not thinking about numbers at all, just sort of lining up chairs, and they've not really done any repacking of the specific physical environment into abstract maths. Or they could be thinking, oh, I've got 4 and 4 and 4 and 4, and then they're doing semantic waves in their head, perhaps. This is kind of one of the things I've thought about a lot with what I do, is sometimes I'm the one who's doing all the work, doing the repacking, and it's the activity that you come up with, exactly what you're saying. You can come up with activities that force them to actively do the repacking themselves. And so understanding what's going on, you need to know not only what the teacher's saying, but really be interviewing some students and finding out what they were doing, or listening to their verbalizations if there's some of that going on.
So in my study, that's why I found doing just a single teacher case study was really useful, because in my lesson observations, I could take photos of what the pupils were doing on their whiteboards or in their notebooks. I could listen into what they were saying and make notes of it, as well as we're not just looking at what one person is doing. This is a study about what's happening in a social environment, which is the school classroom. So yeah, absolutely. So you could take, for example, that my example with the fraction 2/4 earlier, and in one classroom, actually the semantic density could be very low because their understanding of that is so early on that it's very simplistic. But if I'm working with some 13-year-olds, probably as soon as I put that fraction up, if they've got a lot of prior understanding, then actually they're operating in quite a semantically dense way, potentially, because they can connect that representation to lots of things within their heads. It depends on the context that they're using it, I think, is what you're saying. So yeah, absolutely.
And I just say, I mean, another thing that I've been thinking that's linked to how we use it in computer science is an important thing about a representation in computer science is what does it make easy to do and what does it make difficult to do. So Roman numerals, for example, are relatively easy to add, but they're a nightmare to multiply, whereas place number arithmetic allows lots of other things to be done. Binary allows to multiply by 2 really easily. Is that sort of something that's coming up as part of this, that different representation? I'm just trying to work out in my head how that relates, because it feels like if you choose the right representation, you help people move a step further because of what they can do with it. The representation of chairs is really good physically because you can move them around really easily, for example, and put them onto roads, and that's part of what makes it work.
The way I think about it is very similar to that, is that different representations will enable you to think about different aspects of a concept, kind of like you're saying. And actually, for me, part of semantic density, a higher level of density, is actually where if I can connect up more than one representation, I can see how this one connects to this one, connects to this one. That's quite dense, because now I'm having to think about all these different viewpoints of a concept, if you like, rather than just using one. So that's why in the translation device, if I go back to it, for density, it was important that for a high level of semantic density, that this is connecting, for me, this is about connecting multiple representations, especially given that right back earlier, what I was saying, that the challenge is for teachers to help pupils make connections between multiple representations. That's an important part of them developing this kind of deep understanding. So yeah, this is the idea that what's going on in the environment, in the classroom, is essential in terms of being able to interpret this representational activity. So again, for those of you that are new to this, you can put the two things together like this, and it enables you to start thinking about semantics in terms of code. So if I've got something and we think, okay, well, it's very context dependent and it's not very dense, it's quite simple, we would say, oh, it's given the name prosaic code. If something is up here and it's not dependent on a context at all, it's got a low amount of semantic gravity compared to other examples, and it's very dense and complex, it's rhizomatic. So we can start to kind of think about these things in terms of semantic codes. So these are the definitions that I've taken from Carl's book. I'll just give you a minute to read them again if you're not familiar. It's quite a lot to take in. And then we'll look at some real data from my study in a minute, which will hopefully stimulate some thinking.
I think these sorts of concepts are a lot easier to explain rather than allow people to read.
Yeah.
You know,
well,
you can get through this much quicker by saying like, and I would start with rhizomatic, go to prosaic, then to worldly, and then rarefied in that order. I find that the easiest order to do.
Okay. Well, maybe if we look at some examples from my data, we can start to think about it. And in fact, we can look at that example of the chairs first. I find that quite a useful one to think about this. So I would, if I was watching a teacher and some students use this, and it was just looking at this and they were saying, right, can you put these in rows? I would say this is not particularly dense, and it's very contextualized with this idea of putting the chairs into rows. So this would be a prosaic code. Sorry, let me go back for a minute. However, actually, what would happen if the teacher said, okay, well, I want us to use what we know about times tables to find all the possible ways of putting them into equal rows? Well, it becomes much more dense then, because I'm now having to connect my knowledge of times tables with this thing that's putting chairs in the rows. And actually, I could start to even use counters to represent it, and it becomes even more dense and less related to the context. So you can see that from a single starting point, a teacher, what happens in the classroom, I feel, can start to make what I would call a kind of a pathway through these, and the sort of semantic gravity and density are shifting and changing as that, I guess, a maths lesson is progressing. So in this example, we may have started off in a sort of prosaic code, moved to a worldly code where it's still context dependent, but it's becoming more dense and more complex. And actually, as we move away from the chairs and start to think about counters and writing it as times tables, we're actually becoming less context dependent gradually. So there's a kind of a pathway going on here, and we're starting to perhaps move into a rhizomatic kind of realm. And if the teacher was to then say, can we write down all of the different possible ways they can put them into rows just by writing out our times tables, our factors of 24, then we're going to become much further away from the initial context of chairs or even counters in rows. So hopefully that kind of demonstrates like the different codes and what they might actually look like in a maths lesson. So what I'd like to do now is just look at actually some of my data from my case study with you and show you how I interpreted it, and maybe we can have some discussion. So I think this slide just actually tells us what we've already talked about. Yeah, we need to understand how representations are being used, and this just goes back to the point earlier. Like if we put 1/4 on that representation up, you could have a high or low level of density depending on like prior knowledge and how they're using it and that kind of thing. So just to give some understanding, what I did with all of my data, I split it up into segments, because remember what I'd done was watched maths lessons and done interviews about the math lessons, and I had my observation notes from the lessons as well as the video, and I put it into segments. So these segments were essentially bits of data that were all related to a segment of the maths lesson, and there's a whole rationale behind how I segmented the maths lesson, but we don't need to go into that right now unless you want to ask. So this is an example of a segment. I think on the next slide I've got it slightly bigger, so it might be able to see, you might be able to actually see it. So this is one segment. So you've got my lesson observation notes at the top. You've got the image that the teacher had on the screen. So that's the image she put on the screen. And so this is a segment. So I'll just let you have a look at the data and read my notes for a minute. So remember, I also had the video as well that I could go back and refer to during my analysis of this. So my interpretation of this is that it's pretty context dependent. It's about a jam roll. There's actually seems to be not particularly much maths, depending on how you want to interpret it, going on. It's just they're talking about splitting a jam roll up. So it's not very complex. They're just splitting. I've said not mathematically complex because you could say folding a piece of paper into 12 equal parts is complex, but maybe in a different way. but from a mathematical point of view, not particularly complex. And three main representations here. So we've got the image of the jam roll on the screen, the pupils had paper, strips, and there's language here being used to refer to the 12 equal pieces. So as a data segment, I took this and I thought about semantic gravity and semantic density. And I felt that this kind of fell around here. So it's very context dependent, so a high level of semantic gravity, and it's not particularly dense. So it falls into this kind of prosaic code. And you may have noticed that as well, and I'll come back to this, but this was something she was doing right at the start of a maths lesson that I was watching. So this is one data segment and how I interpreted it. So before I move on and show you another one, has anyone got any questions about this one in particular before we talk about another one and how it compares, I guess?
Andy, can I ask a question?
Yeah.
So you have designated cutting a roll of paper into 12 equal pieces as a prosaic activity, i.e. SG plus and SD minus. So it's context dependent and it's not very complex. Did you do that with your head on your shoulders or from the student's perspective?
As in,
so in other words, as somebody put in the comment there, that is relatively simple for you as an experienced mathematician, whereas for the students that you're teaching, it might be in a different quadrant.
Yeah. So I was trying to understand it, not so much from if I had to do it, but for the students. So these were, I think they were 11 years old, 10, 11 years old, and folding the paper up into equal parts was actually something they have been doing for the last few years when learning about fractions. And so when I even spoke to the teacher, it was a deliberate decision for her. She told me that she felt this was something that they would find fairly straightforward mathematically. I'm not talking about they were folding it. So the actual physical folding of paper into equal parts is difficult. But from a perspective of fractions, thinking about a piece of paper split into 12 equal parts for them, what was relatively simple, I think. Does that answer the question?
Yeah, so it was dependent. So your decision to put it into the prosaic quadrant was essentially based on the previous experiences of these students, so what they would have been taught to date.
Yeah, and my observation in the lesson and from talking to the teacher.
Okay. Thanks for clarifying that. Thank you.
Yeah, no, that's fine. No, it's useful to have because it's so easy when you're so immersed in all this to kind of assume that people are going to realize things like that. So that's quite a helpful thing for me. Yeah.
Thanks.
But as with all this stuff, it's open to interpretation. So for me, the relativity of this is really important. And so that's why seeing it in terms of the translation device and also seeing in terms of other data, which I'll show you another example in a minute, it is quite important. So let's look at another one. This is another segment, data segment. So this was on the screen in the lesson. So this is from the textbook she was using. Next to the screen, there was a flip chart and the teacher had drawn this on it. And just to give you the context, this drawing on the flip chart was in response to a student who had spoken in front of the whole class to say what they had drawn on their paper. So this is the teacher's drawing of something that a student was trying to explain. And these are my sort of notes from that section of that the lesson. So I'll let you just read them for a minute. So I guess the key thing to pull out here is that although in the textbook task it's talking about pizzas, how much pizza was there left, actually in the lesson, the pizzas were way forgotten. There was no conversation of pizza. And the whole discussion, the pupils drawing representations, the teachers' representations there, it was all about fractions and how they can subtract fractions in different ways. So although it mentions pizza, they had kind of left that behind in the lesson. So I thought about, again, this data segment, and for me, it fell into a rhizomatic code because there was a high level of density. They were having to connect circular, rectangular diagrams to abstract representations using the symbols. And on top of that, they were having to think about 2 different methods that they could think about using those 3 different representations. So for me, it was really dense. Actually, not just for me, but for the teacher and for the pupils, it was really dense. It was a complex thing for them to be doing. But also, I feel that this was a low level of semantic gravity because we had moved right away from the initial context, which was pizzas and this children sharing pizzas, eating some pizza. And they were now just really thinking about fractions and different ways to manipulate this abstract idea of fractions. So they were becoming more generalized in their thinking. So for me, that one was kind of fell here as a rhizomatic code, especially when you think about it relative to that first example. So before I move on and show you kind of what I'm going to show you is where I plotted all the data segments and pick out a particular pattern I noticed. Any sort of questions or comments about this segment? Anything that people wanted to know or things you noticed? I'll take silence as a no for now. So if you then think about the whole data corpus, so all of my data, all the segments from, this is from 2 lessons. This is sort of where they fell. So you'll notice we didn't have anything that fell into a rarefied code. But something I particularly noticed in the 2 lessons that are plotted on here is that they tended to start in either a prosaic or a worldly code, where the complexity was quite simple and the things were quite heavily contextualized. But they would often move fairly quickly into a more dense meaning as the teacher asked them to make connections to other representations or different pieces of knowledge they had about maths. And that actually throughout the lesson, there was this kind of pathway that by the end of the lesson, they often ended up working with very abstract things that weren't particularly context dependent and often very dense in meaning. So lots of different representations being used together, multiple representations being used, often to explore different ways of doing things. So this was a sort of pattern I noticed in Gillian's lessons. And so what I'm not saying is every single maths lesson looks like this, but what I'm saying is this kind of demonstrates perhaps how we can use semantics to really analyze classroom practice in relation to representations and start to trace some of these pathways and make some suggestions about what's actually going on in a classroom and actually explaining this idea of representational activity. So I want to just pause there for a minute and just again invite any sort of comments or questions about my interpretation and my kind of reading of this. Any sort of thoughts that people have around it?
So one thing, you can go further than you just said. It's not just about explaining what's going on, and it's actually improving things. So, what you're doing there is just sort of moving from one area to another. If you were thinking this more in terms of waves, thinking about whether this is actually a wave going on and how you could improve the waviness of it. I mean, going to the pizza example, the thing I was thinking, if I was teaching that, I would be going backwards and forwards between the fractions and the diagrams that were supposedly actually pizza. And I'd be dividing the pizza up into 6, say, to show this idea of, why have we turned the fractions from a half and halves and thirds into 6? And then, if you were then going backwards and forwards between the maths and the numbers and the maths and the numbers, then you would be doing waves. So in using it in that kind of way, seeing what somebody's doing, and then sort of it can actually then tell you, and here's something to think about, you've drawn that diagram, how can you use it? How can you go backwards and forwards? How can you do waves with it to make people think about actually strengthening the practice that they're doing based on what they're already doing, just by tweaking it a little bit.
Yeah, absolutely. So importantly, thinking right back when I showed you that table, which was the sort of summary of what previous literature and research had talked about in terms of using representation. So in the lessons I saw, Gillian was doing actually all of those things. So you could say, according to other research, she was using representations effectively. And I think you're right. What this does is actually help us understand in a perhaps more temporal way and dynamic way, like actually what does that look like in a maths lesson? And then actually how can I make sure I'm doing more of that as a teacher? But the other thing I would say is that also as a teacher, how do I make use of a resource such as a textbook or a scheme? And actually, how do I bring that to life and use it effectively in the classroom? Because that's another key area that we know in teaching in general is actually using a given resource. So I heard a question perhaps there, but I maybe cut someone off. Maybe not. I heard a noise.
I mean, I got some unprocessed connections because this is new. It's absolutely fascinating, Andy, like really interesting. It's making me think of task and activity that John Mason and Sue Johnston Wilder talked about, or they sort of popularized something by some Danish maths educators about a distinction between a task which is offered and how a teacher makes that available. And there's the notion of opportunities to learn. And I think what you're presenting to us here is a way to get to grips with that, which is absolutely fascinating. It's also making me think, and I'm new to LCT and this semantics analysis. But I'm thinking there's a particular description of a mathematical problem-solving cycle that distinguishes between the real world, and we mathematize that into a mathematical world. We might do some analysis in that, and then we recontextualize it. We interpret the mathematical result back into the real world, and I see that sort of here as well. So I'm just in the process of making lots of connections and seeing how it fits, but it goes further as well. And as the point that Paul just made and that you picked up on, it sticks with your will to be pragmatic. It's actually talking about classroom experiences and how teachers act and how learning happens. So it's fascinating.
Yeah.
Matt, can I just add to that? It's really interesting because you just described within mathematics is how the same thing we see everywhere, which is, the kind of coming from the empirical up into the theoretical, translation to there, working in there, coming back down into the empirical, probably working there a bit too. And that is those semantic waves. And it's so fascinating to me how this appears. One of the problems with education research is that it's like medieval Europe. It's like loads and loads and loads of tiny little mini states, none of which talk to each other. And it's amazing how we see semantic waves in all these different forms in all these subfields like mathematics education and various other places, when we're all actually looking at the same problems, which is like dealing with how do we do these waves as, instead of flat lines. So that's fascinating. But I'm really pleased to hear that. Well, that's what I'm saying, Matt, because we haven't done enough work in maths, to be honest. Done loads of work in loads of other subject areas, but it's interesting to hear it. Yep, here it is again in another subject area.
I would actually say as well, since doing this, I've used this in doing professional development with teachers as well, helping teachers to interpret their own classroom practice and think about their own classroom practice in terms of this. And yeah, it's really quite powerful in terms of getting them to really reflect, a bit like what you were saying, Paul, on what do I do and how can I do more of the stuff that works. Yeah. So I've stopped sharing so I can actually see everyone now. That's kind of the end of what I was thinking. So if I was just going to summarize, I think there are three main things here. Firstly, the LCT semantics can really support this kind of how we analyze the communication of meaning in a more nuanced way by sort of tracing those pathways that I was showing you, and help teachers to reflect on what's happening. And I think that will mean that we can develop a better, more clear understanding of this idea of representational activities. So really building on what previous people have done to understand representations and things, and actually start to think about what is happening in lessons, in these social interactions with teachers and students. I also think that there is something in actually using it to understand how teachers interact with their teaching materials, such as schemes and textbooks and things, because though all of those things have given representations and things, but actually this is how teachers bring them to life and enact them in the classroom. And I think that interaction between curriculum materials that have been written by experts and used by teachers, and then the actual using them is a key part of this sort of recontextualization. Yeah. So I'll stop talking. I mean, I'm interested if there are any other questions or comments or thoughts about any of this. I think it's fair to say even though I finished my doctoral study, it's something that I keep reflecting on and refining my own understanding and knowledge of, because it is complicated.
Just wanted to add, Andy, firstly, thank you, and we'll say thank you in a minute. But one of the things that's come out through this discussion is something you wouldn't have seen it because I put it in the chat, even though I told people not to put in things into chat. I just cut and pasted a little bit out of the draft 8 of Sociology of Possibility, which is the book I'm writing and have been writing since the dawn of time, which is there is no single semantic density or semantic gravity of anything. So some people have this essentializing mindset of thinking that a particular piece of knowledge, whatever you want to call it, has a particular semantic density. And then somebody else will go, yes, but people can read it in different ways. An expert will see a lot more complexity in it than a beginner. Of course, the point is semantic density is for analyzing what's in front of you, to try and solve a problem. So we're trying to decide what we need to analyze. This is exactly what you're doing, which is how the teachers are going about using this stuff. So there may be a diagram may have a potential semantic density that's huge. And then, the teacher uses it in a way which is very, very simple. It's not about finding the definitive answer of what semantic density is in this thing, which is very essentializing. It's more, how do they use it? So it's always about practice, which is why I very rarely ever use the word knowledge in anything I've written without saying knowledge practices, because it's to try and avoid that reifying of knowledge as if it's not part of some sort of practice, whether it's writing or research or teaching or developing a curriculum or chatting with someone or whatever it might be. There's always in the practice itself. And we always try and, when we're figuring out relative strengths, is to solve a problem as well. It's not to say this is a definitive model of the world. We don't model the world. We just try and present ways of understanding and solving problems. So I think you've done the right thing there. Again, another potential pitfall that we kind of identify is, kind of skirting around these things that don't help us solve problems, like the essentializing mindset that tries to find a definitive thing as if that helps. It's like it doesn't help try and figure out how to teach the damn thing.
Yeah.
I mean, it's really interesting, Paul, Carl, sorry. The things you're saying there, and you're kind of saying you recognize some of the stuff that maybe I said in your context, and I'm like that happens the other way around. I mean, Andy and I know each other in a maths education context, and I don't want to take it too far down that, but this notion of an opportunity to learn that, as you say, it could go really far. I'd say that's something which is acknowledged and well understood by some in maths education, in UK maths education. Some teachers, educators will talk about designing tasks and offering tasks which are low threshold, high ceiling is the notion. So it's that notion that everyone can get through the door, But how far you go with it, which we can now describe in terms of semantics, is, well, the sky's the limit, really. And it's just a little window into the whole of the discipline of mathematics. Yeah, there's no reason to not to do that, but let's not slip down the onto-epistemological hole. Actually, we've got a lesson, we've got kids in here, but there's something. Now it gets into agency and what the teacher's doing. And Andy, you started off with the kind of the distinction that's worth saying between mathematics and school mathematics, and that is part of what's going on here too. But there's agency, there are decisions which are made by teachers in what they offer, and indeed what they seek to notice, and maybe what they do notice. So there's a development of expertise by the educators. And then, of course, about the actual learners themselves. They're meeting new ideas for the first time, appropriating them, some would say constructing the ideas for themselves. And this just gives a lot of purchase, Andy, into like ways to describe that. It's fascinating.
Thank you.
Can I ask something? Is there time for a quick question?
Yeah.
Andy, I would be very interested. Did you show your teacher, Gillian, or whatever you said her name was, the profiles of how the pathways that she kept taking? And then, also, is there potential for her to, I suppose, say, well, instead of rhizomatic, ending with a rhizomatic, what would happen if I went back to the I think picking up on what Paul said, about that continuous waving, and but I was just wondering whether you used it as a tool for getting her to think about possibilities she might not have considered.
Yeah, I didn't do that as part of the study, although I have since done that with her, because one of the sort of things I wanted to do once I'd done it was actually look at it with her. And so an early part of the analysis was before I got to that point, we looked at some of my initial data analysis, but I hadn't quite got to that point when I did that with her. So I think it would have made it a better study if I had done that, but unfortunately not. But what you're saying is definitely what I've been doing with teachers more recently, is getting them to think about different kinds of lessons and where they might want to end up. So your lesson doesn't have to always end up in that rhizomatic area. Actually, sometimes you might go, okay, now we've learned this complicated and decontextualized concept. Can you apply it to a real world situation now? And that's quite difficult. We're not saying that this rhizomatic point is the end point. Actually, sometimes it's even harder to then go back down again. So that's definitely something that I've been doing, but it didn't form part of that study, that I've been describing. I think
Rita.
Yeah.
Rita.
Yes, thanks, Andy. This is such a wonderful discussion. I just wanted to find out from a research point of view, because it's something I'm always struggling with. How do you bracket off your own thinking around whatever you're doing and separate it from what the teacher needs to do and what is happening in the minds of the students?
So for me, I took the stance where I didn't do that. Actually, I took this as a study where it was a co-creation of meaning. So essentially, I view it as the knowledge that came out of this study was co-created by me and Gillian as the participant. So any themes or interpretation inherently had to have my own kind of stuff in there as well. So rather than trying to bracket it off, I wanted to, it's that idea of reflexivity, where I wanted to be really aware of everything I was thinking and my own standpoint and my place as an insider researcher as well. So I had techniques like I kept a journal throughout the whole process so I could make notes of my thoughts as I was going along and make reference to that in the analysis. So what I've shown you today is a small part of some of the data and analysis. There was other stuff that was going on around that I guess perhaps would answer that question better, Rita. Does that make sense?
Oh, yeah. Thank you.
Yeah. got a few other hands up as well, I think.
Rolene.
Yeah, can I?
Yeah, thanks very much, Andy. I found this extremely interesting and valuable, and especially for my students sitting here, because as part of their final year research project, they actually video recorded an entire lesson and mapped the semantic gravity and density profiles of their lessons and the plane. And the question I want to ask you, because I see that you are taking your research further with your teachers, what is currently very difficult for my pre-service teachers is analyzing the unpacking and the repacking. Let me just say outright, in the South African context, there's a lot of focus on algorithms and learning. And so most of their profiles, flatlined. And so it was very important for me to use this framework, them to understand and explain and unpack and repack. So the question I'm asking is, why is it so difficult? And what is important? Well, I have an understanding, because the way in which I ask them to focus on their knowledge practices is by going back and unpacking the knowledge. So instead of focusing merely on representations, of course, there was representations, but I did a kind of, to the best of my knowledge, an in-depth analysis of the concepts and sub-concepts and the representations, all connected in a schematic, representation that I call the object of analysis. But I'm really interested to hear from your context. Are teachers also struggling with, evaluating, the profile in terms of the unpacking and the repacking of their lessons?
I would say the short answer is yes, it is difficult and they are struggling. In my experience, certainly if I think about this study with Gillian as well, there are certain things which support it. And so one of them is having so she used a textbook, and the design of that textbook. So I told you earlier, I did a textbook analysis. The design of that textbook very much supported that classroom practice, as you say, packing and unpacking ideas. So that was, from that study, that was a particular thing of note, was that the tool she was using, so the textbook, really was aligned with what she was doing in the classroom. It was supporting her, I think. But not from that study, but certainly from my experience, part of the problem is that teachers were taught, if they weren't taught in that way, they tend to just fall back to how they know from experience, unless there's something that's going to disrupt that, that's going to prompt a change. So for Gillian, using that textbook, and she had professional development associated with it, was probably, I would take a guess that was one of the key things that had sort of disrupted and changed her practice. Does that make sense? So thinking about what tools teachers are using that support them to do it, rather than having, because it's a lot of knowledge. So I used that example with fractions earlier, knowing that all those representations relate to fractions and the best way to use them and what order is really, really complex, I think. So having things out there, supportive tools that help teachers to do it is important, I think.
People are having to go rapidly, and we are over time. So let's just a couple of more questions. So can we be brief?
I just want to comment on that. I agree with you, but what I found with my pre-service teachers is that if they really have a limited understanding of the deep connections within the mathematics, it restricts them from exploring or optimizing the deep connections they can make.
No, I'd agree.
Again?
Hey, thank you, Carl. Thank you, Andy. Very interesting and wonderful talk. Multiple representation in mathematics, really interesting topic. I was wondering, in your translation device for SG of the different representations, would you consider the different forms of the representations will influence your analysis of the SG? because it seems to me that your criteria of analyzing ESG of different representations more focus on the content they present. What about the different forms of the representations themselves? For example, taking the diagram of the chair arrangement example, so you showed us a diagram, right? And what about the teacher using verbal language to describe the same concrete situation? So how would you measure the two different forms of representation? Would you consider the forms themselves as a factor influencing the SG of the representation themselves? Because the diagram depict a concrete situation, but verbal language is symbolic.
Yes.
So
yeah.
forms in the same influence your analyze of the SG. So that's my question.
Yeah, so I think so the way I approached that was, rather than to analyze representations discretely, I was looking at, okay, so in this segment of a lesson, there is language, which, as you say, is abstract and symbolic. You've got this image of the chairs, but being used in conjunction with one another, that forms that one situation, that social situation. So rather than analyzing the discrete, like just the language or just the image, I was analyzing that segment of social interaction. Does that make sense? I think I hope that answers your question. Yeah.
Yeah, it's very interesting because you touch upon the different forms of representation, because you also consider language a part of your representation. Yeah. So I was wondering, okay, diagram, they presenting the depicting the situation, but language is symbolically describing. There should be some difference, but how to capture that might be interesting. Yeah.
I think it would be really interesting, slightly different avenue for that research. But yeah, I think definitely it's interesting.
Thank you. Thank you very much.
I think that's why we in LCT, we put such store by the questions you're asking, not just the objective study, because when Shikang's made a really interesting question, really interesting issue to study, but that's for a different question, I think. But it's definitely an interesting issue because of the different ways of representing. But I shouldn't talk because I've forgotten what Jolene, is it?
It's Jennifer. I'm really sorry.
Jennifer,
I did that.
Sorry, I keep forgetting.
I did that ages ago, and now I've forgotten how to change it back. I'll have to go and do it. So it's Jennifer. Thank you.
Did you want to say anything?
Yeah, I'm in physics, and so this is very applicable to what I do and what I've talked about. And I think it was Paul or Andy, I can't remember which one, was talking about, or somebody was talking about the possibility of coming back down again afterwards. And Paul made a comment about how this is similar to semantic waves, which is a concept that I am a little bit familiar with, certainly with sort of putting it against time, as it were. And you specifically mentioned semantic pathways, Andy, and then I'm wondering about, I know that there's a thing called autonomy tours, but perhaps semantic tours, and what the difference perhaps between those things are, the waves and the tours and the pathways. Yeah, I don't know if that's particularly clear what I'm actually asking.
So I've not come...
Sorry, go on. How different are they? How different are they really?
I've not come across, I've never used autonomy as one that I mentioned, so I'm not familiar with the tools. But I think what I was showing, I have attempted to start to think about it in terms of representing it with semantic waves. So I think they're because it's semantics, they're kind of similar. They're just different ways of representing what I was talking about. The difficulty with semantic waves, it's hard to show the density and gravity. Like it's tricky to show them, I think, together. If that makes sense.
Yeah.
Just to answer that question, Jennifer, we can use pathways with any dimension. We can use profiles with any dimension. So you can have semantic tours, you can have semantic one-way trips. We don't know what they mean much yet, but the analytics are separate from the dimension. So
yeah, because you were asking on the email groups about, has anybody used these, and please send you examples.
Yes. Yeah. That's because while I'm writing the book, I'm kind of trying to make it very clear, because profiles were introduced at the same time as semantics. Some people think they are locked together, and because pathways and tours and so on were presented at the same time as autonomy, because I did too much in both those papers at the same time, they think they're locked together. So in the book, I'm making very, very clear that you can have semantic tours, you can have, autonomy waves, you can have like the analytics, the visualizations are separate from the dimensions. And that's why I was saying on the email forum, if you've done a semantic tour, please let me know, because I want to be able to exemplify them. But I've got to bring us to a close. This is amazing. I love it when there's too long and everybody starts leaving too early, unfortunately. So you don't get to see the quiet applause of Zoom. Thanks, Andy. But a lot of people have written in the chat saying thanks so much for this talk. When everybody leaves, I'll leave it there so you can read it if you want, Andy, before I close down and so on. And I say thanks everybody for being here and for joining in. What a fantastic discussion there's been. And please join us again in 2025. Please write to me and let's do one. Or you could do, several people can do one. We've had them in the past where we've had 3, 2. They can be like several students doing parts of a roundtable. We can do anything we want with this space, as long as we use it. If we don't use it, then it will just not happen. So get in touch with me and we'll do this stuff. Thanks so much for everyone being here.